Hi everybody, this is Notes 42. Please make sure that you are an honors student. If you are not an honors student, you're going to want to find the other video. This is the wrong one. So, awesome. If you are an honors student, welcome. We're doing polynomial factors. You can determine if a binomial is a factor or not. So today we're going to use our division from our previous lesson. So if you haven't done 38 yet, this lesson's going to feel pretty confusing. So I would highly recommend going back to 38, especially because it will be on your quiz this week anyway, so good to know. So if we verify factors, if we're thinking about how to find factors, right? So 30, if I'm thinking about the box 30, I know that I can put 6 and 5 here because those are factors. They don't have any remainders. I don't think that I can put a 6 and a 7 here, right? A 6 and a 7 wouldn't get me the right answer. Let's backtrack. Let's try the number 4, right? So if I put 4 times 7 is 28, and then there's a remainder of 2 left over. So I don't want to deal with any remainders. That's how I know that 4 is not a factor. The same thing is true here. If a binomial is a factor, when divided, the remainder should be 0. We should have no remainder left over, so nothing left over after we finish our division. So what we're going to do, it says, is x minus 1 a factor of this function here? So we'll put x minus 1 on the side. And then we're going to use our division skills. Remember, we're trying to see what the remainder would be. So we have x to the third, put x squared on top. X squared times negative 1 is negative x squared. I need these two boxes to give me positive 2x squared. So I'm going to have 3x squared because 3 minus 1 is positive 2. That gets rid of that guy. X times 3x is 3x squared. 3x times negative 1 is negative 3x. I know these two boxes need to give me negative 2. Negative 3 plus 1x would give me that negative 2. So x times 1 gives me 1x. 1 times negative 1 is negative 1. That's what I'm looking for there. I'm all done. There is no remainder. So because there's no remainder, just like when we had 6 and 5, we knew that those were factors of 30, we know that x minus 1 is a factor of f of x. All right, so we would say that that's our answer. This question was a yes or no. Is it a factor or not? And we would say, yes, this is a factor. All right, so that's if we want to verify if it's a factor or not. Same thing, we're going to follow through when we're factoring completely. So we're going to take it one step further. If we know one of the factors, then we could find the others. So I'm going to go ahead and say x plus 7 goes here. I'm going to quickly do my division. I'm not going to talk through it so much. If this is confusing, a reminder to go back to module 38. There's a really good video there. It goes through a lot of examples. So x times 2x squared is 14x squared. These two boxes need to make negative 10. So I need negative 24x squared. I have negative 24 x. 24 times 7, I'm going to use my calculator. 24 times 7 is 168. X. And then I'm going to backtrack to my problem because, whoa, this isn't working out, right? There shouldn't be anything here. I shouldn't have that remainder. So I'm going to look back at my problem. I'm going to notice that I made a critical error. This problem right here would be there's a negative there, right? So because of that negative there, we're going to have to start my problem over. So pretty good example of what happens when math teachers make mistakes too. So let's try this again. Hopefully this will work out better this time. So I have x plus 7, negative 2x cubed. It's going to give me negative 2 x squared here this time. Gives me negative 14 x squared. That makes this math a little easier to get to negative 10. I just need a 4 x squared. That's going to give me 4x on top. and 28x. That's going to cancel out that last piece, which means this is totally done. That looks way better. So now what I know is that this x plus 7 times this negative 2x squared plus 4x are my two factors. And what they're asking me here is to factor the polynomial completely. Focus on that word completely. So I know there's nothing I can take out of x plus 7, but there is something I can take out of here. I see that they have a common x, and I see that they have a common 2. So I'm going to take the 2 out to the front. It's going to leave me with negative 1 and positive 2. And then I have x squared, which is x and x, and I have x here. So I'm going to take this x and that x to put one outside, and then there's 1 left here. So I can see that I have 2x, x plus 7, negative 1x plus 2. Right? If I distributed that 2x back in, I would get my original equation. There's nothing I can take out of any of these factors, so that is my answer. I have factored completely. Right. That's the second kind of problem that we'll see. And then there's one more, which is this one here, finding solutions. So if we know one of the solutions, we can find the others. So one of the solutions is 10. That means that x equals 10. If I use my reverse, or I flip the sign, I know that x minus 10 is equal to 0. This is one of my factors. So this problem all of a sudden is very similar to the earlier problems. I know that x minus 10 is a factor. I have 4x third. So I have 4x squared, negative 40x squared. 40 minus 16 is 24. So I have 24x squared here. That's a 24x. Gives me negative 240x, which is what I have right here. So this problem is complete. So I can say, all right, x minus 10 is a factor, and 4x squared plus 24x is also a factor. From there, I need to take out whatever I can, just like on my previous problem. So I'm going to see what I can divide out of each of these pieces. I know I can divide a 4 out, and I know that I can also take an x out of each of those. So that's going to leave me with 4x out in front, the x minus 10 from before, and then 4 divided by 4 cancels. X squared divided by x leaves me with just 1x, plus 24 divided by 4 is 6. The x's divide to 1, so I'm left with just 6. I know that from there, if I'm finding my solutions, I have to find where it would equal 0. So here, I'd say x equals 0. That one's pretty easy. This one, I would say x equals 10, flip the sign. And this one, I would say x equals negative 6. So I know that my solution, or my function, has 3 solutions. If I was graphing it, I know I'd go through x equals 6, x equals 0, maybe x equals negative 6, and x equals positive 10, right? If I backtrack here, I can see, oh yeah, it's x to the 3rd power. So it would make sense that we go kind of up like this, maybe down like that, and back up that way through that 10. Right? So we can see a pretty simple graph. Alright, this is pretty complicated. There are 3 distinct sections on your homework, but please ask questions. And we'll talk to you soon. Thanks.